In this video, we will be reviewing the properties of exponents and using those to simplify expressions. So let's begin. If we have a to the b power times a to the c, then we can rewrite that as a to the b plus c power. Excuse me. So whenever we have the same base and we're multiplying, we can add the exponents. Whenever we have the same base and we are dividing, we could rewrite that as a to the b minus c. So that would be, when we're dividing, we have the same base, we subtract the exponents. If we have a to the negative b power, we can rewrite that as 1 over a to the b. Alright, if we have a to the b to the c power, we're going to say a to the b times c power. Here we have a times b all raised to this power. We're going to have to raise a to the c power and b to the c power. Same thing when we are dividing. We would have a to the c power over b to the c power. This one might be kind of new for you. We have a to the 1/n power. We can rewrite that as the nth root of a. So anytime you have a to the 1/n power, you can rewrite that as the nth root of a. Here we have a to the m over nth power. We can rewrite that as the nth root of a to the nth power. Alright, so let's practice those. Here we have a to the 6th times a to the 7th. We can rewrite that as a to the 6th plus 7 power, which would be a to the 13th power. Alright, here we have a to the 7th over a to the 5th. We can rewrite that as a to the 7 minus 5 power, which would just be a squared. Here we have a to the negative 3rd power, so we can just rewrite that as 1 over a to the 3rd. Here we have a squared to the 4th power, so that would be a to the 8th power, because we would say 4 times 2, and that would give us 8. Here we have a times x to the 2nd power, so we're just going to have to square each term, so we have a squared times x squared. Here we're dividing, so it's going to be a similar thing. We'll have a to the 5th power over x to the 5th power. Here we have 4 to the 1/2 power, and what we need to do is rewrite this as the square root of 4, and since we know that the square root of 4 is 2, we could just go ahead and simplify that to 2. Here we have x to the 2/3 power. If we want to rewrite that into a radical, we would say that that would be the cube root of x squared. So the denominator is always the root that you're taking, and the numerator will be the exponent you have under your radical. Okay, so that was a quick review of exponent rules. Let's use them to simplify a few problems. Here we have 3x cubed y to the negative 2 squared times 2x to the negative 2 y cubed. So let's start by simplifying what's in the parentheses and being squared. So we would say 3 squared times x to the 3 times 2 power times y to the negative 2 times 2 power. And we're just going to leave this the same. So 3 squared is 9. This would be x to the 6th power. This would be y to the negative 4th power. This would be times 2 x to the negative 2 y cubed. So what we need to do here is simplify. We have some negative exponents, so I'm going to put those in my denominator. So I'm going to have 9x to the 6th over y to the 4th times 2 y cubed over x squared. We can go ahead and multiply these. So that's going to give me 18 x to the 6th, y to the 3rd, over y to the 4th times x squared. We can simplify this. We have x to the 6th and x to the 2nd. So that would be 18 x to the 4th. This would be on top over y to the first power. You can write the 1 or you can leave it, because 3 minus 4 is 1, and it should stay on the bottom here. Okay, let's look at this one. We have 32 to the negative 2/5 power. So I'm going to start by rewriting this as 1 over 32 to the 2/5 power, because that's what that negative means, write it as a reciprocal. So I have 1 over the 5th root of 32 squared. The 5th root of 32 is 2, so 1 over 2 squared is 4. Right, and then here we have 6 over 6 to the 3/4. Remember, this is an understood 1, so we have 6 to the 1 minus 3/4 power, which would be 6, and I'm going to say 6 to the 4/4 minus 3/4. That just helps me with the fractions. So that would be 6 to the 1/4 power. So in this video, we reviewed the properties of exponents. We did a few examples, and that's about it.